On this 2010 to 2015 Honda Civic, B1276 points to the headlight switch position circuit in the body electrical lighting system. In plain terms, the MICU may be seeing a combination light switch input that does not match the switch position. The vehicle may have exterior lighting behavior that does not line up with the switch, or the problem may only show up in scan tool data. The broad possible fault areas are the combination light switch, the switch signal wiring, the switch ground path, and the MICU in the under-fuse/relay box. We are going to diagnose it by watching the switch inputs, then separating a switch fault from a wiring fault or MICU fault. Start in the lighting data list and watch the combination light switch inputs while moving the switch through OFF, parking, auto, and on, headlight. With the switch OFF, headlight switch OFF should read on, and parking, auto, and headlight should read OFF. In parking, OFF should read OFF, parking should read on, auto should read OFF, and headlight should read OFF. In auto, all four listed inputs should read OFF. In on, headlight, OFF should read OFF, parking should read on, auto should read OFF, and headlight should read on. If all of those values are correct, treat it as an intermittent failure for now. The system is okay at this time, so check for loose or poor connections. If the values are not correct, keep going with the circuit checks. Next, check the combination light switch data list value again. The key question here is whether the value is OFF, not on. If the suspect data value is OFF, move ahead to the jumper test at the switch connector. If it is not OFF, continue by disconnecting the switch so you can see whether the switch itself is pulling that input on. Turn the ignition switch to lock 0, then disconnect the combination light switch 12P connector. Go back to the data list and see whether the value changes from on to OFF. If it does change from on to OFF with the switch disconnected, the diagnostic path calls the combination light switch faulty. If it does not change, the switch is not the reason that input is staying on. So move to the short to ground check between the switch circuits and the MICU connector. For the shorted wire check, leave the ignition switch in lock 0. The combination light switch 12P connector stays disconnected, and you also disconnect under-fuse/relay box connector T, 20P. Then check continuity to body ground on each of the switch signal lines individually. H/L OFF/SW from connector T, 20P no. 1. ORN to body ground. H/L on SW from connector T, 20P no. 2. PNK to body ground. And parking LT/SW from connector T, 20P no. 3. GRI to body ground. If there is continuity, repair the short to ground in the wire. If there is no continuity on that path, the diagnostic result is a faulty MICU, and the repair path is to replace the under-fuse/relay box. If the earlier data list value was OFF, use a jumper wire at the combination light switch 12P connector to ground the switch inputs one at a time. Connect connector no. 1. ORN to body ground. Then connector no. 7. PNK to body ground. Then connector no. 8. GRI to body ground. Watch the data list while you do this. If the value changes from OFF to on, the wiring and MICU side responded, so the diagnostic path calls the combination light switch faulty. If the value does not change from OFF to on, continue to the open wire and high resistance check. For the open wire check, turn the ignition switch to lock 0 and disconnect under-fuse/relay box connector T, 20P. Now check continuity end to end on the switch circuits. Check H/L OFF/SW between connector T, 20P no. 1. ORN and combination light switch 12P connector no. 1. ORN. Check H/L on SW between connector T, 20P no. 2. PNK and combination light switch 12P connector no. 7. PNK. Check parking LT/SW between connector T, 20P no. 3. GRI and combination light switch 12P connector no. 8. GRI. Then check combine SWGND LT between connector T, 20P no. 5. BLK and combination light switch 12P connector no. 6. BLK. If continuity is present where checked, The diagnostic result is a faulty MICU, and the repair path is to replace the under-fuse/relay box. If continuity is not present, repair the open or high resistance in the wire. After the repair, keep verification separate from the fault isolation work. Repeat the original data list check through OFF, parking, auto, and on, headlight, and confirm the values now match the switch positions. The takeaway on B1276 is simple. Do not guess at the switch or the MICU. Use the data list first, then use disconnect, jumper, short to ground, and continuity checks to prove which side of the circuit is wrong. For more diagnostic training, visit Diagnostics.com.